Okay, so continuing from our last video, this is where we ended, and then in this video we are going to see a more complex VLAN other than the one that we did previously. So okay. Okay, so physically, you will say PC1 and PC3 are on the same network, and then PC2 and PC4 are on the same network. Logically, after creating VLANs, PC1 and PC2 are going to be on the same network, whilst PC1 and PC3 are on different networks. So I have two separate subnets here, 10.1 and then 10.2 and 11.1. So what we are going to do here is we're going to configure an IP address for each of these PCs, and then we are going to configure our trunk over here. Trunk here allows multiple VLAN network to be transferred from one switch to the another in tag frames, and then the tag frames are done using .1q tagging to tag the VLAN traffic being coming from a different switch to another switch. So it will make more sense if you take in the practical aspect. So at the moment, I will start these nodes up and configure the IP addresses. So I'll configure an IP address for PC1 and it's 10.10.10.1, and by default it's using a subnet of 255.255, which is /24 notation. Okay, so I'll go to PC2 and start PC2, configure PC2, choose an IP address of 10.10.10.2, and I'll start on PC3, choose an IP address of 10.10.11.1, and I'll start PC4. IP 10.10.11.2. So physically, you will say these PCs are on the same network as I said earlier, so as these PCs. So let's go to our switches and then create our various VLANs on it. So I'm going to create a VLAN on these switches and then create a trunk port for these switches, and I'll put each separate port into either VLAN 2 or VLAN 3. So I'll go ahead and start the switch. So I'll do show IP interface brief. Interface 00 is connecting to PC1. Interface 0001 is connecting to PC3, and then interface 02 is going to be configured as a trunk. So at the moment, we will check our VLANs. Show VLAN brief, and at the moment we have VLAN 2, VLAN 3 already configured. I was using it for the testing, so I'll go ahead and then delete the various VLANs. VLAN 2, no VLAN 3. So show VLAN brief. At the moment we have no VLAN, and by default every port on the switch is configured to be in the native VLAN, which is VLAN 1. Okay, so first of all, I will create my VLAN 2, name task. That is it. VLAN 3, name task. So I will check our available VLANs, and now we have VLAN 2 and VLAN 3 up and running, right? So one thing I will do is have to disable the VTP mode, because if I do show VTP status, at the moment we are transparent, and then at transparent the current VLAN configuration on this switch won't be propagated to the connected switch, and then in the subsequent videos coming we will talk about VTP, right? So at the moment okay, so I'm going to start the switch. It's already started, and I'm going to ping PC3, ping PC3, and there is no gateway. And for PC1 be able to ping PC3, we'll need a gateway. And then when we get there, in the subsequent videos, we are going to configure this layer 3 switch to have a gateway so that we can ping each other. So at the moment, I am going to interface 00 E00 switch port access VLAN 2. Exit. So at the moment, this port connecting to PC1 is in VLAN 2, and then I'm going to Ethernet/1 switch port access VLAN 3. And what I just did was to put the interface connecting to PC3, which is Ethernet 01, to VLAN 3. So I'll do show VLAN brief, and at the moment I have VLAN 2, which is active on Ethernet 01.00, which is connecting to PC1, and I have VLAN 3, which is active connecting to PC3 on Ethernet 0/1, right? So let me go ahead and configure this switch. Console. So on this switch, I already have the VLANs configured, VLAN 2 and VLAN 3 at the moment. Show VTP status. Sorry. Okay, the server. It doesn't matter for now. When we get there, we get to understand what is going on. Right. So what I'm going to do here is I'm going to put PC2 in VLAN 2. So what I'm going to do is Ethernet interface E0/0 switch port access VLAN 2, and then I'll drop back to configuration mode, and then I'll configure interface 0/1 switch port access VLAN 3. So just like I did on this network, I have configured similar on this network. So logically now, PC1 is in VLAN 2, sorry, and then PC2 is in VLAN 2 also. And as you can see, you have VLAN 2 on the left side of the network logically. So PC1 and PC2 are connected together. Now we have PC3 over here in a separate subnet and having the same subnet as PC4, and they are on VLAN 3. Now somebody will say, okay, so logically if PC1 and PC2 are now on the same VLAN, they should be able to communicate. So let's try that to see if they will be able to communicate. So I'll go ahead and ping PC1, which is PC2 10.10.10.2, and as you can see, it's not working. Right. So as I said earlier on, when we configure VLANs on a different network, like a separate network line, just like we have here, this one is a separate network line, here's a separate network line, and it's being joined by one line. And as you can see here, I have .1q trunk over here. Before VLAN network can move from one switch to the another, if you pass through a trunk, and basically trunks are used for transferring VLAN traffic, and it uses tag frames. So there will be VLAN 2 traffic coming from here, VLAN 3 traffic coming from here. When it gets to this line, they're going to be tagged by the VLAN number before it reaches this switch, and then it distributes to the various ports in this various VLANs with its respective ports assigned to it. So what I'm going to do is I'm going to configure a trunk on this port and then here too. So I'll go to switch 1 and I'll do conf t and I'll do interface 0/2. That's the interface where the trunk is going to be configured on switch 1. So switch port trunk encapsulation .1q. So basically what it's going to do is it's going to turn the port into a trunk with the .1q frame tagging. So we are done for here, and I'll switch the port to trunk, switch port mode trunk, and we are good to go. So at the moment, if I do show interface is running on trunks, you will see ET02 is on and it's using the encapsulation .1q tagging, and it's trunk, and it's on native VLAN 1. Okay, so let me go ahead to PC2 switch 2 and do the same configuration over there. So interface is /02 and then switch port trunk encapsulation .1q switch port mode trunk. So show interfaces trunk on ET02 on switch 2, the trunk mode is on, and at the moment we should be able to ping PC1 to PC2. So I'll go ahead and ping, and as you can see, it's now working. So physically they are on different network segments, but logically PC1 and PC2 are binding together. And then in our previous video, I showed you how frames from the same VLAN, from PC6 to PC5 had no frame tags. They were just Ethernet frames. So I'm going to start a capture here. Start a capture, and I'll start a capture here before. After it enters this switch, being transferred to this switch, we are going to see the tag.1 kill tagging over there. Okay, start a capture. Okay, so Wireshark is running. So let's try to ping PC3 to PC4 to see if it will work. Okay, so ping 10.10.11 the 2. So we are pinging PC4 and voila. So they are on separate network segments, but they are able to communicate with each other logically. They happen to be on the same network. Okay, so I'm going to try another ping to PC2 for us to capture the frames or the packets being transferred from PC1 as it's being tagged from switch 1 to switch 2 before it gets to PC2. Right, so let's head to Wireshark, and then this one is PC1 to okay, from PC1 to the switch 1. I'm going to search for ICM ping, and as you can see, PC1 has found out a destination 10.2 for PC2, and as you can see, the frames are just Ethernet frames. They are not being tagged, and as you can see, the destination and the source, they are just Ethernet frames. So after it enters the switch, we are going to analyze what happens. So from switch 1 to switch 2, where we have the encapsulation taking place. So here is switch 1. Here is PC1. That's the traffic from PC1, the first frame, the ping request to PC2. And as you can see, after the Ethernet frame, this is destination, this is the source. We have the encapsulation over here. And as you can see, the VLAN ID is 3. So that's how VLANs work in complex networks. So for traffic from a different network segment, probably VLAN to communicate with traffic on or to communicate with devices on a different network, on a separate network, we need, first of all, we have to get our VLANs created, and then mostly we have our trunk. The trunk is the most important thing, which is going to carry VLAN traffic over the network. And as you can see, we have the .1 kill encapsulation tagging on this trunk, and that is what we are seeing here. It's OQ virtual LAN as the tagging, even before it turns into IPv4 address. So this is one way to go about VLANs from basic understanding to more complex understanding. Thanks for watching.